Best morning, everyone! I'm Gizelle Caparanga from Regional Science High School 3, and welcome to BioTalk with Gizelle. Are you excited to learn?
My friend here has type 1 diabetes, and after she ate lunch, her glucose levels are rising continuously. How do we save her?
Insulin therapy! You got it right! With that, do you want to learn more about what we've just encountered? For this lesson, our objectives are to define, explain the processes, and state the importance of genetic engineering. Here we go! Are you wondering where human insulin for diabetics comes from? It is manufactured by the E. coli bacterium and certain yeast strains. But how do these microorganisms produce human insulin? Through genetic engineering, a process under biotechnology which is the applied biology. Genetic engineering is the manipulation or changing of the DNA of an organism. It involves removing a target gene from one organism, which is called the donor, and transferring it to another organism, which is referred to as the recipient. The recipient is called a transgenic organism or a genetically modified organism. Do you want to know how genetic engineering really works? Let me show an example of how the insulin gene is inserted into a bacterium in order to manufacture large amounts of human insulin. Step 1. Remove a plasmid from a bacterium. Step 2. Cut it open with some restriction enzymes. Step 3. Locate and remove human insulin gene, which is found in chromosome 11 at position 15.5 from a person's DNA using those same restriction enzymes. Then, combine that insulin DNA with the plasmid using ligase enzymes. Step 5. The bacteria are incubated with a new recombinant plasmid. The bacteria will then take up that plasmid and start to produce the insulin. Once completed, the bacteria will reproduce millions of times, passing on that gene to all subsequent bacteria as it reproduces asexually. They have now become a culture of many factories, all producing human insulin. The insulin is then extracted, purified, and packaged. A population of diabetic patients can now inject themselves with human insulin, and that is how genetic engineering works. Meanwhile, the importance of genetic engineering stems from its applications in different fields. In medicine, genetic engineering has been used to mass-produce insulin, growth hormones, vaccines, and many other drugs. Another purpose, for example, is the introduction of a gene from a bacterium that produces a toxic chemical into a maize plant to make it harmful to specific insects that eat it. Now let's test how much you've learned. Ready? Go! Let's check your answers. That's it for our video. I hope you did well and learned a lot. Keep safe and happy learning!